Hello students, this is class 3 of geography. So today we will talk about interior of earth. Earth is divided into earth जो है most importantly तीन पार्ट में डिवाइड हुई है. This is core, inner part, this is mantle and this is crust. Mantle is further divided into upper mantle and lower mantle, and core is also divided into upper core and inner core. So we know that earth is divided into concentric layers. These layers are known as crust, mantle and core, and the radius of earth is greater than 6000 km, and therefore the study of interior of earth is very difficult. और अर्थ की जो रेडियस है वो 6000 किलोमीटर से ज़्यादा है, इसीलिए हम अर्थ के इंटीरियर में जाके स्टडी नहीं कर सकते हैं. अर्थ के इंटीरियर को स्टडी करने के लिए वी हैव टू सोर्सेज, डायरेक्ट सोर्सेज एंड इनडायरेक्ट सोर्सेज. डायरेक्ट सोर्सेज में क्या है? फर्स्ट, डिगिंग अ होल. दिस इंक्लूड्स स्टडिंग डीप माइंस एज वेल एज डीप ओशन ड्रिलिंग प्रोजेक्ट्स. तो अगर हम माइंस को डिग करेंगे और ओशन के जो ड्रिलिंग प्रोजेक्ट्स को भी डील करेंगे तो उसमें हम कुछ किलोमीटर तक इंटीरियर ऑफ द अर्थ को स्टडी कर सकते हैं. बट मैक्सिमम जो अभी तक जो डेप्थ है वो सरफेस पे 3 किलोमीटर है, और जो ओशन सरफेस है, लैंड सरफेस पे 3 किलोमीटर है और ओशन सरफेस 12 किलोमीटर है. तो अभी तक हम 3 किलोमीटर लैंड सरफेस तक पहुंच सके हैं और ओशन सरफेस तक 12 किलोमीटर. एज वी गो डाउन, pressure and temperature both increases, so due to which we have been able to go up to the depth of 3 km on the land and 12 km on the ocean surface. So what is the first direct source to study about the interior of the earth? It is digging a hole. So the second source is studying of volcanoes. So the study of volcanoes gives the idea about the interior of the earth, but volcanoes mostly occur from the depth of 2000 km, which is the layer of asthenosphere, and thus volcanic eruption can give us the idea of only up to the 200 km and not beyond that. So mainly, what are the direct sources to know about the interior of the earth? It is digging a hole and study of volcanoes. Now we will talk about indirect sources. Direct sources में there is meteors. So by studying the meteors, we can conclude that the inner part of the earth is made up of very dense material. This is because meteors enter the earth. When they enter the earth, their upper part is burned, exposing the core. So core might be made up of very hard material, that is why it couldn't be burned. Secondly, studying the temperature and pressure in the interior of the earth. So as we go inside the earth, temperature and pressure increases. Fine. The rate of increase of temperature is more in the upper part, because the upper part is dominated basically by the radioactive minerals, which lead to the increase in the temperature, and as we go deeper along with the temperature, pressure also increases. Hence most of the earth except the outer core is in solid form, and the asthenosphere, which is up to the 200 km, it is in jelly like. Third, we can know about the interior of the earth by studying the seismic waves. So seismic wave is very important, so we will talk about it in detail. So seismic waves are generated during the earthquake. So what is earthquake? Earthquake is shaking of earth, during which energy waves are generated, and these energy waves are of two types: body waves and surface waves. These waves travel in all directions. So Some waves are generated inside the earth and some generated outside the earth. Earthquake release energy in the form of waves. Some waves are generated inside the earth, while some waves are generated outside or on the surface of the earth. So, the waves which are generated inside the earth are known as body waves, and the waves which are generated outside or on the surface are known as surface waves. So, this wave travel inside the earth and this wave travel on the surface of the earth. When earthquake occurs, there is release of energy in the form of waves, और ये waves दो type की होती हैं, body waves and surface wave. Body waves are generated inside the earth and they travel inside the earth, and surface waves travel on the surface of the earth. So now we will talk about body wave and then surface wave. So body wave is of two types, P waves and S wave. So this is our earth and this is inside the earth and this is the surface of the earth. So when earthquake occurs, suppose this is the epicenter and this is the focus or hypocenter. So as we know that body waves travel inside the earth, so this will travel. So some waves will bend because different layer is made up of different material, some are in solid, some are in liquid, so the waves will bend accordingly. Focus is always inside the earth and it is the part where waves are generated. And what is the epicenter? Epicenter is always on the surface of the earth and it is nearest to the focus. It is point where maximum impact of earthquake will be seen. Now we will talk about body wave. So as you already know that body wave is of two types. Secondary wave, we can also call it as secondary wave. So P waves are the first wave to arrive at the surface. So the speed and direction of the body waves are the best sources to study the layered structure of the interior of the earth. So what are the properties of P waves? Before talking about the properties of P wave, we will talk some important point about secondary wave. So P waves are the first wave to arrive at the surface and secondary waves travel with half of the speed of P waves. Secondary waves are transverse waves, fine. So body waves are of two types, P waves and secondary waves. Now what is the property of P waves? P waves are the first waves to be recorded on the seismograph. Seismograph पे this is the wave P wave which is recorded first, और ये सिमिलर है साउंड वेव की तरह, बिकॉज ये तीनों मीडियम में ट्रैवल कर सकती हैं. सो वी कैन से दैट इट इज़ सिमिलर टू साउंड वेव एंड द स्पीड ऑफ अ पी वेव इज ग्रेटर इन द डेंसर मीडियम. P waves are recorded first on the seismograph. Seismograph is an instrument which is used to measure the intensity of the earthquake. Second property is it is similar to sound waves as it can travel in. And third, the speed of the P wave is greater in the denser medium. Fourth point is that P waves undergo compression and rarefaction. So P waves will stretch and squeeze the particles, causing deformation of the rocks. Due to the stretching and squeezing of the particles, there is deformation of the rocks and the rocks move parallel to the direction of wave propagation. So this is compression, and this is rarefaction. Fine. Now the next property is that this is the fastest wave. Now we will talk about S waves. We know that P wave is the fastest, so S wave travel with half the speed of P waves, and therefore they are the second wave to be recorded on the seismograph. In S wave, the particles move up and down, that is perpendicular to the direction of the wave propagation, and in P waves, the particle moves in the parallel to the direction of wave propagation, and this wave can travel only in solid, medium. But we already know that P waves can travel in all the three medium, that is solid, liquid and gas. So how these waves help in studying the interior of the earth? How these waves help to know about the interior of the earth? As the waves travel in the interior of the earth, there is change in direction as well as velocity of the waves. So the change in the direction and the velocity is due to the change in the densities of the medium through which P and S wave pass. When the waves move from crust to mantle and mantle to core, there is sudden bend and change of velocity of the waves. The boundary of the crust and mantle is known as Moho discontinuity, and the boundary of the mantle and the core is known as Gutenberg discontinuity. Core is further divided into two types, inner core and outer core, and the inner core is of solid and outer core is of liquid. So S wave does not pass through the liquid medium. So the property of S wave, that it cannot pass through the liquid, help us in understanding that outer core is in liquid form, because the S wave does not pass through the liquid outer core, and hence the shadow zone of an S wave is greater than the shadow zone of an P wave. It is shadow zone. So I will draw one diagram. Please understand it carefully, it is very important from exam point of view. So we will draw the shadow zone of S wave. So we know that S wave does not travel through the liquid medium, it travels only through the solid medium, and we also know that outer core is in liquid medium, so S wave will not travel in outer core. This is S wave. This is inner core, this is outer core, and this is the mantle and this is the crust. Fine. So this is talk about P wave. We will see here how, through the diagram we will see how P waves travel. So this is P waves. See how it bends as it travels through different medium. So now the shadow zone of S wave will be from here to here. Shadow zone of P wave will be from 105 to 145 degree. So this will be the shadow zone of 145 degree, 105 degree to 145 degree, and 105 degree to 145 degree, and the shadow zone of S wave is from here to here. So we can see from the diagram that the shadow zone of S wave is greater than the shadow zone of P wave. So please note that the shadow zone of S wave is greater than P wave. It is very important. the shadow zone of S wave is greater than the shadow zone of P wave. P wave shadow zone appears as a band around the earth between 105 degree and 145 degree away from the epicenter, and the shadow zone of S wave is beyond 105 degree.